The National Electrical Code, also known as NEC, requires a minimum of a 30-amp circuit for electric ranges. The International Residential Code, also known as IRC, also requires a 30-amp circuit for electric ranges. According to the instruction book, a 30-amp circuit is required for the range. Based on these requirements, number 10 copper wire is suitable for a 30-amp circuit. Since the range is already connected with a 50-amp cord, it is likely either incorrectly wired, meaning it should be using a 30-amp cord, or it requires a higher capacity circuit, which is not generally recommended. Based on the 30-amp circuit requirement, it can be estimated that the range has a maximum power consumption of approximately 7,200 watts. This is calculated by multiplying 30 amps by 240 volts. Based on the manufacturer's recommendation and electrical codes, the 30-amp circuit with number 10 copper wire is appropriate for the combination gas and electric range. It is important to verify that the 50-amp cord is not connected to the range. If it is, disconnect it. Run a new 30-amp circuit using number 10 copper wire. If there are any concerns or further assistance is required, consult a licensed electrician. Firstly, understand the National Electrical Code requirements. The NEC provides the standardized guidelines for electrical installations to ensure safety. For electric ranges, including combination gas and electric models, the NEC mandates a minimum circuit amperage to handle the appliance's power demands. Secondly, consider the International Residential Code. The IRC mirrors the NEC in specifying the electrical requirements for residential buildings. It's essential to comply with both codes where applicable to ensure the electrical installation meets safety standards. Thirdly, review the manufacturer's recommendations. The appliance's instruction book is a key resource. It details the specific electrical requirements for the model, including the recommended circuit amperage and any unique considerations. Always prioritize the manufacturer's guidelines, as they are tailored to the appliance's design and function. Fourthly, select the appropriate wire size. The wire gauge must be adequate for the circuit amperage to prevent overheating and potential fire hazards. Number 10 copper wire is commonly suitable for a 30-amp circuit. Consult the NEC or a qualified electrician to confirm the correct wire size based on the installation conditions and local codes. Fifthly, address the existing 50-amp cord. If the range is currently connected with a 50-amp cord, it's crucial to investigate the wiring setup. The cord may be incorrectly wired, meaning it should be replaced with a 30-amp cord that matches the circuit amperage. Alternatively, the range may require a higher capacity circuit, but this is typically not recommended unless the appliance's specifications explicitly call for it. Sixthly, estimate the kilowatt rating. While the kilowatt rating for the range may not be readily available, it can be estimated based on the circuit amperage. Multiply the circuit amperage, such as 30 amps, by the voltage, such as 240 volts, to calculate the maximum power consumption in watts. Divide the wattage by 1000 to convert it to kilowatts. This estimation provides a general understanding of the range's power demands. Seventhly, follow the recommendations. Based on the manufacturer's instructions and electrical codes, install a 30-amp circuit with number 10 copper wire for the combination gas and electric range. Ensure the wiring connections are secure and comply with local electrical codes. If the range is currently connected with a 50-amp cord, disconnect it and replace it with a 30-amp cord that matches the circuit amperage. Eighthly, verify the wiring connections. Double-check that all wiring connections are properly made and tightened. Loose connections can cause overheating and potential electrical hazards. Use appropriate wire connectors and follow the manufacturer's instructions for making secure connections. Ninthly, test the circuit. After completing the electrical installation, test the circuit to ensure it is functioning correctly. Use a multimeter to verify the voltage and amperage readings at the outlet. Check for any signs of overheating or other abnormalities. If any issues are detected, consult a qualified electrician for assistance. Tenthly, consult a licensed electrician. If there are any concerns or uncertainties regarding the electrical installation, consult a licensed electrician for guidance. A qualified electrician can assess the situation, provide expert advice, and ensure the installation complies with all applicable codes and regulations. Additionally, understand ampacity and wire gauge. Ampacity refers to the current carrying capacity of a conductor, typically expressed in amps. Wire gauge is a standard measure of wire thickness, with smaller numbers indicating thicker wires. The appropriate wire gauge for a circuit depends on its ampacity. For example, number 10 copper wire is commonly used for 30 amp circuits. Number 12 copper wire is often used for 20 amp circuits, and number 14 copper wire is frequently used for 15 amp circuits. It's crucial to select the correct wire gauge to prevent overheating and potential fire hazards. Next, consider conductor material. Copper and aluminum are common conductor materials used in electrical wiring. Copper has higher conductivity and is more resistant to corrosion than aluminum, making it a preferred choice for most applications. However, aluminum is lighter and less expensive than copper, so it may be used in some installations, particularly for larger conductors. When using aluminum conductors, it's essential to increase the wire size to compensate for its lower conductivity. Also, you have to understand insulation types. Electrical wires are insulated with various materials to prevent short circuits and electrical shocks. Common insulation types include thermoplastic high heat resistant nylon coated, also known as THHN, thermoplastic heat resistant, also known as THW, and cross-linked polyethylene, also known as XLP. Each insulation type has different temperature ratings and environmental resistance properties. Select the appropriate insulation type based on the installation conditions and local codes. Next is conduit and cable types. Electrical wiring is often installed in conduit or cable assemblies for protection and support. Conduit is a rigid or flexible tube used to enclose and protect electrical wires. Common conduit types include rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Cable assemblies consist of multiple wires bundled together in a protective jacket. Common cable types include non-metallic sheathed cable, also known as NM cable, and armored cable, also known as AC cable. Also, you have to understand overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds a predetermined level. Fuses are one-time devices that melt and interrupt the circuit when the current exceeds their rating. Select the appropriate overcurrent protection device based on the circuit amperage and the ampacity of the wiring. A 30 amp circuit, for example, typically requires a 30 amp circuit breaker or fuse. Next, we have to understand grounding. Grounding is a critical safety measure that provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock hazards. Electrical circuits must be properly grounded to ensure safety. Grounding conductors are typically made of copper and are connected to the grounding electrode system, which consists of grounding rods, ground plates, or metal underground water pipes. Also, we must know about electrical boxes. Electrical boxes are used to enclose wiring connections and provide a safe and convenient location for installing electrical devices, such as outlets, switches, and light fixtures. Electrical boxes are available in various shapes and sizes to accommodate different wiring configurations. Metal and non-metallic electrical boxes are both commonly used. Metal boxes must be grounded to provide an additional layer of safety. Next, we need to understand wiring methods. Electrical wiring can be installed using various methods depending on the application and local codes. Common wiring methods include concealed wiring, where the wires are hidden inside walls or ceilings, and exposed wiring, where the wires are visible and accessible. Concealed wiring is typically used for residential and commercial buildings, while exposed wiring may be used for industrial applications or temporary installations. And finally, you need to understand local codes and permits. Electrical installations must comply with all applicable local codes and regulations. These codes may vary depending on the jurisdiction. It's essential to obtain the necessary permits and inspections before starting any electrical work to ensure compliance with local requirements. Consult with a local building department or a qualified electrician to determine the specific codes and permit requirements for the project. The estimated power consumption of 7,200 watts is a useful figure for understanding the range's electrical demands. This estimation is based on the assumption of a 240-volt supply, which is standard for most residential ranges. However, the actual power consumption may vary depending on the range's specific features and usage patterns. For example, if the range has a self-cleaning oven, it may draw more power during the cleaning cycle. Similarly, if multiple burners are used simultaneously, the power consumption will be higher. To accurately determine the range's power consumption, refer to the manufacturer's specifications or use a power meter to measure the actual usage. The information provided emphasizes the importance of using number 10 copper wire for a 30 amp circuit. This recommendation is based on the ampacity of number 10 copper wire, which is typically rated for 30 amps under normal conditions. However, it's important to consider the specific installation conditions, such as the ambient temperature and the number of conductors in a conduit, as these factors can affect the ampacity of the wire. If the installation conditions are such that the ampacity of number 10 copper wire is reduced, it may be necessary to use a larger wire size to ensure safe operation. The mention of a 50 amp cord raises a red flag, as it suggests that the range may be connected to an oversized circuit. Using a 50 amp circuit with a range that is designed for a 30 amp circuit can be dangerous, as it can lead to overheating and potential fire hazards. The overcurrent protection device, such as a circuit breaker or fuse, is designed to protect the circuit from overloads and short circuits. If the circuit is oversized, the overcurrent protection device may not trip in the event of a fault, allowing excessive current to flow through the wiring and potentially causing a fire. It's crucial to disconnect the 50 amp cord and replace it with a 30 amp cord that is properly matched to the range's electrical requirements. Additionally, verify that the circuit breaker or fuse protecting the circuit is also rated for 30 amps. The advice to consult a licensed electrician is sound, as electrical work can be dangerous and should only be performed by qualified individuals. A licensed electrician has the knowledge, skills, and experience to safely and correctly install electrical wiring and equipment. They can also ensure that the installation complies with all applicable codes and regulations. Hiring a licensed electrician can help to avoid potential hazards and ensure that the electrical system is safe and reliable. When selecting an electrician, it's important to choose someone who is licensed, insured, and experienced in residential electrical work. Ask for references and check online reviews to get an idea of their reputation. It's also a good idea to get multiple quotes before making a decision. In addition to the information provided, there are a few other factors to consider when installing a circuit for a range. Firstly, the location of the range. The range should be located in a well-ventilated area away from flammable materials. The range should also be installed on a level surface to prevent it from tipping over. Secondly, the type of fuel. Ranges can be powered by gas, electricity, or a combination of both. Gas ranges require a gas supply line, while electric ranges require an electrical circuit. Combination ranges require both a gas supply line and an electrical circuit. Thirdly, the size of the range. Ranges come in various sizes, from small apartment-size models to large professional-grade models. The size of the range will affect the amount of power it consumes. Fourthly, the features of the range. Ranges come with a variety of features, such as self-cleaning ovens, convection ovens, and warming drawers. These features can affect the amount of power the range consumes. Fifthly, the age of the range. Older ranges may be less efficient than newer models. If you have an older range, you may want to consider replacing it with a newer model to save energy. The process of running a new 30 amp circuit involves several steps. Firstly, turn off the power to the existing circuit at the main electrical panel. This is a crucial safety precaution to prevent electrical shock. Secondly, identify the location where the new circuit will be installed. This may involve running wiring through walls, ceilings, or floors. Thirdly, install a new electrical box at the location where the range will be connected. The electrical box should be sized appropriately for the wiring and the receptacle. Fourthly, run number 10 copper wire from the main electrical panel to the new electrical box. The wire should be run through conduit or cable assemblies for protection and support. Fifthly, connect the wires to the circuit breaker in the main electrical panel. The black wire should be connected to the breaker, the white wire should be connected to the neutral bus, and the green or bare copper wire should be connected to the ground bus. Sixthly, connect the wires to the receptacle in the electrical box. The black wire should be connected to the hot terminal, the white wire should be connected to the neutral terminal, and the green or bare copper wire should be connected to the ground terminal. Seventhly, install a 30 amp circuit breaker in the main electrical panel. The circuit breaker should be labeled to indicate that it is for the range circuit. Eighthly, turn on the power to the new circuit at the main electrical panel. Ninthly, test the new circuit to ensure that it is functioning correctly. Use a multimeter to verify the voltage and amperage readings at the receptacle. Check for any signs of overheating or other abnormalities. The recommendations include verifying that the 50 amp cord is not connected to the range. This is an important safety precaution, as using an oversized cord can lead to overheating and potential fire hazards. The cord should be replaced with a 30 amp cord that is properly matched to the range's electrical requirements. If the range is hardwired, meaning it is directly connected to the electrical wiring without a cord and plug, the wiring should be inspected to ensure that it is properly sized and connected. The wiring should also be protected from damage. The recommendation to run a new 30 amp circuit using number 10 copper wire is based on the electrical codes and the manufacturer's recommendations. Using the correct wire size is essential for ensuring safe operation and preventing overheating. The wire should be run through conduit or cable assemblies for protection and support. The conduit or cable assemblies should be properly secured to the building structure. The recommendation to consult a licensed electrician is sound, as electrical work can be dangerous and should only be performed by qualified individuals. A licensed electrician can assess the situation, provide expert advice, and ensure that the installation complies with all applicable codes and regulations. Hiring a licensed electrician can help to avoid potential hazards and ensure that the electrical system is safe and reliable. Additionally, be aware of electrical safety tips. Always turn off the power to a circuit before working on it. Use insulated tools and wear appropriate safety gear. Never work on electrical wiring in wet or damp conditions. Inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Do not overload electrical circuits. Use extension cords sparingly and avoid running them under carpets or furniture. Keep electrical appliances away from water. Test ground fault circuit interrupter, also known as GFCI, outlets monthly to ensure they are functioning correctly. Install smoke detectors and carbon monoxide detectors in your home and test them regularly. If you experience any electrical shocks or unusual electrical problems, consult a licensed electrician immediately. By following these safety tips, you can help to prevent electrical accidents and ensure the safety of your home and family. Remember, electricity can be dangerous, so always take precautions and consult with a qualified electrician if you have any questions or concerns.